This is Unit 3, Lesson 7, example number 4. So triangle ABC and triangle DEF are drawn on the right. If AB is congruent to DE, notice I'm annotating my diagram. AC is congruent to DF. And angle A is congruent to angle D. Write a sequence of transformations, meaning there's going to be more than one, that maps ABC, which is our pre-image, onto triangle DEF, which is our image. Okay, so notice if I start at A and go counterclockwise, I have ABC. And if I start at the corresponding part D and again travel counterclockwise, I get DEF. So since the corresponding parts are in the same order, right, A goes to D, B goes to E, C goes to F, orientation did not change. So orientation is preserved, meaning no reflection took place. Okay. So what had happened? Somehow this triangle slid onto the other one and then turned, right, to get into the same position. So what I said happened first is I said a rotation centered at C. I don't have a protractor. I can't tell you how much it rotated, but I know something happened. So then I have a triangle that looks like this. And this would kind of be like my B prime and my A prime, for example. Followed by, okay, well now they kind of look like they're in the same direction. I just need this one to lie on top of the other, so I would have to slide it over. So a translation. And I need to name a vector. Again, the vector is just the direction that it goes in. It connects a pre-image point to a corresponding image point. So I know that C corresponds to F. So translation by vector CF. What are some other vectors I could have listed? Starts at B and ends at E. Or starts at A and ends at D. Any of those would be fine. So a rotation centered at C, followed by a translation of vector CF, right, will map triangle ABC onto triangle DEF. Could I have identified a different order or a different rotation with a different center? Absolutely. Okay, depends on what you see. So I could have maybe said a translation of CF followed by a rotation centered at F. Perfect. Done. Okay. Could I have referenced another vector and rotated about another point? So if I said B to E and then I rotated about B, sure, absolutely. Okay, so there is a variety of ways to explain or describe a sequence of transformations. Notice I didn't use any mathematical notation. I wrote it in words. Mathematical notation is not required when it says to write a sequence or describe a sequence.